hand it over to our illustrious master, Jordan Hubbard.
Hello. So I'm Jordan Hubbard. I've been using FreeBSD for longer than anybody in this room.
This is before it was FreeBSD.
Yes, from before it was FreeBSD. I'm the CTO of IX Systems. Before that, I was at Apple for 12 years and worked a lot on OS X and iOS. So this presentation will be covering something that Kip and I and a few other folks at IX Systems have been working on kind of in our copious spare time. We're facetiously calling it NextBSD. That's just a code name for it. AKA FreeBSD 10, but 10's already taken, see, so it's FreeBSD only goes to 11. But let me talk a little bit about the basic architecture, and then I'm going to also turn it over to Kip and let him talk a little bit about the mock IPC that he's brought in. So a fundamental foundation of NextBSD is mock IPC. And one of the things that most people don't know about BSD is actually it's had mock code in there since almost the beginning. The mock VM system, yes, there have been changes made to it over the years, but the original BSD project certainly took some stuff over from Carnegie Mellon as it was evolved in the mock project. And somewhat coincidentally, some of the guys behind mock at Carnegie Mellon also went to this little company called Next back in the 90s and were very influential on the evolution of NextStep, and then later OS X. Avi Tevanian was my first boss at Apple, and he was one of the key architects in mock. So a lot of the DNA runs deep there, and of course OS X still uses the mock VM code, so if you look at the OS X or OSF, the mock OSFNK sort of sources that underlie it, you're going to see a lot of similarities. So bringing mock IPC into FreeBSD wasn't actually the kind of impedance mismatch most people would think it could be. On top of that, we have the Common Object Runtime, which I'll get into more in a minute, actually after Kip does a little bit more of a deep dive on mock IPC, and then various libraries which have dependencies on the common runtime and provide significant functionality in their own right, and then of course the most controversial piece, LaunchD, and the various things that talk to it. But let's first, let's double click on that. So would you like to take it, this is Kip's section of the talk. So
This is very short, so
yeah.
just bear with me.
Okay.
So the one thing that really had to be added to the kernel was mock ports. And because LaunchD, I mean, I keep hearing that Apple is phasing out mock and all that, and I don't really see any support for the claim in their code, although they're doing a much better job of hiding it now that they have something called XPC, which provides an actually like 20th century API to mock ports. Because the one grievance that I do have with mock port, mock IPC, is that the API is unrefined.
Yeah, it's very 90s.
It's 80s.
80s.
It's rough.
Yeah.
And anyway, so this is just the basics of what how mock is characterized, taken from somewhat plagiarized from the Apple site. And what mock calls tasks are basically just a synonym for processes, and in order to provide some of the bits for a mock task, I just added a bit of extra state to the proc structure. Threads are essentially unchanged, although I've added a little bit of private mock state to the thread. The address space, I mean, none of this changes. The API looks very, very similar. Although I've had to add a little bit of APIs for doing zero copy movement of large buffers between address spaces, which I'll get to in a moment. The notion of memory objects, that's something that I haven't done anything with, which is totally unsupported, and I don't know that necessarily will be supported unless some subsystem needs it. And then there's, of course, our ports, everyone's favorite. And they're interesting because they're half duplex. Basically, one process, because port namespaces are in terms of processes, tasks, has the receive right, and then however many processes can have send rights, and send rights are granted, interestingly, by the owning process. And the owning process can in turn pass the send rights to a number of processes. And it can add send once rights, which is interesting. So basically, the process has the right to send a message once to, which is a little weird, but still interesting. And it gives you sort of, in principle, it gives you very granular permissions, because it's not like, this group or that user. It's basically, it can determine at runtime based on whatever policy that, these processes will have send rights to the port. And then there's IPC message queues. Remote procedure calls are in turn a primitive on top of ports. Notifications are part of how ports work. Semaphores and lock sets are technically part of the mock kernel abstraction, but I haven't seen any need to support them, and so at this time they're not, and they may continue to be. The time APIs are just sort of very simplistic shims around existing FreeBSD APIs. You ask yourself, what is a port? Like I said, it's just a half duplex channel, essentially a mailbox that can have up to some preset number of messages appended to it. Ports can be collected into a group by being added to a port set. So a process or a thread can block up receiving threads on a port set, which is essentially receiving on any of the ports in the port set. And then you can actually listen on port sets with KQ. So you can call K-event on a port set or on some number of port sets. And one of the interesting recent extensions to K-event and mock port sets is you can actually receive messages in line from K-event. So basically you call K-event, you pass it a pointer to a buffer, tell it how big the buffer is, and it provided the messages that size or smaller. When you return from K-event, if you can have received a message into that buffer, it will tell you how big the message is, which is a little bit different. And there's no reason you couldn't do this for UDP or whatnot, but it's something that's there now as part of the K-event extensions. In order to be able to send to a port, a process has to have explicitly been granted the right. Port rights, what are called port rights, the easiest way to think of them is as a file descriptor. And just to leverage common code, and actually there are some benefits. It's actually been implemented as file descriptors with a little bit of shimming to the handles that it uses internally. And this means that you can fstat the process and see what ports it has open. So one of the blog posts I read about someone debugging Chrome on OS X is someone went to great lengths to write a simple kernel module to find out that Chrome was leaking ports. Well, that would have been trivial. You just run fstat on the process and you're like, gosh, this has way too many ports. So basically having these crashes where they ran out of ports, and they couldn't actually report the crashes because they ran out of ports to report them.
Doesn't Activity Monitor already show the number of ports, and they would see it going up and up and up and up?
Pardon me?
On OS 10, Activity Monitor, I thought.
Oh, well, maybe on the, yeah, but that doesn't tell you that, I mean, you're not necessarily, I don't know, that may be more recent, and it doesn't tell you what's causing that or when it's happening. So the frequency. And,
So Kip brings up a related point too, which is there are also special ports. And the exception port, for example, is leveraged greatly in OS 10 to do things like bring up Crash Reporter. So when a process crashes, you can actually have another process that's essentially a proxy which says, all right, I'm going to go scrape your stacks for all of your running threads, and I'm going to symbolicate them for you, and I'm going to bring up, essentially a crash report, versus just letting the process crash and hopefully leave a core file in a location that you can hopefully find, depending on what the process's working directory was at the time that it crashed. Right? It's a much cleaner and much more regular mechanism that lets you do things like crash reporting, which turns out to be absolutely invaluable in debugging complex systems.
You may have addressed what I'm thinking about. Is there a notion of having a reserved set of ports so that you don't experience that problem? or you can handle it?
Not really. I mean,
Yeah.
things like, things running you out of ports is a pathological case akin to running you out of file descriptors, right? I mean,
Right.
you can try to do many different things to try and mitigate that, but ultimately, Unix is an operating system that gives you plenty of rope, and you can use that rope to do great things, or you can wrap it around your neck and yank.
And we enjoy it in both. right?
Yes, yes.
And so I guess the simplest way to think of a port is just as a unidirectional socket that with message boundaries. So it's a message. Pardon?
Previously, you can click on the mouse.
Oh, right. So, and of course brings up the question is, well, why do we need this? You know, we can pass file descriptors over Unix sockets and they have permissions. And what's wrong with them? Well, no, nothing. I mean, they serve okay. But one of the nice things is it's a separate namespace for services. You have the Bootstrap server to provide name service lookups. And this is much, I mean, this was done in the 80s, but it's much more akin to DNS than basically munching around in our attempt for FIFOs. It's a little bit, it's generally more scalable, and to our taste, it's a little bit cleaner
Well,
architecture.
and munging around in /temp also requires that you know the name of the socket file that your service was going to write, and you hope that it used some naming syntax. Doing a service lookup is much simpler by comparison. Just give me the service name foo, and here you go. That's how I talk to foo.
So,
So, was it so to make them essentially file descriptors without some extra bits incompatible with the notion of passing the ownership of a port through an x86 and another process?
I'm sorry, could you repeat that?
So,
More
if I
slowly.
understand correctly, it's possible in Mac ports to pass the ownership of a port
Yeah, yeah.
through an x layer
Yeah.
to some other process, right?
Right.
Essentially a task. Does this conflict with the notion of using essentially file descriptors?
Well, actually, the thing is, because of the weird notion of ports, so a file looks the same is the same vnode no matter what process. Unfortunately, ports are asymmetric, and so there's actually something called an IPC entry, and historically that was in Mach and everywhere else in the world. The port rights are indexed into an array of IPC entries, and so when you pass that port right, you're copying, basically passing, and so that IPC entry contains your rights to the port. So the port is, the message queue. The IPC entry is your metadata about what rights you hold to the port. And so, but what I've done is the file structure references the IPC entry because I need to maintain that asymmetric state. So actually passing ports involves some extra locomotion because I can't simply add a reference the way I can to a struct file. And so there are some nuances that I didn't grasp fully when I started that made the IPC entry code a little bit more complicated, but being able to stat a port is nice, being able to fstat the process, having it as a unified namespace within the process to some degree, I think has and also probably makes the community more comfortable that it's not this weird thing all off to the side.
Weird namespace like networking.
Yeah, exactly. So it's a mixed bag. It's not a clear one because it does add some complexity, and when a process exits, I iterate through its IPC entries and clean them up. I mean, it's not as clean as it is in Mach because it's an impedance mismatch internally, but it makes it nicer from the user's standpoint, I think, enough to justify having made that mistake. And so, I'm sorry, go back to your question.
So the question was how to pass ownership, but essentially the ownership is part of the IPC entry. So
Right.
the
So
process
it's separate.
is
So it does get passed, and it has its own IPC entry. The one thing that's interesting is I've added a little bit of a hook so that when the reference to a port is passed, basically I encapsulate the port a file handle, a file pointer inside the port, so I basically can, the same channel can pass both files and ports. So they're basically, so purposes of passing them back. You can give it a set of descriptors and it'll pass them over regardless of whether or not they're ports, sockets, you name it. They just can't be KQ because KQ passed. And then, so the kernel is a peer, which is kind of interesting. So the kernel can send a process messages. Process can send the kernel messages. I mean, this is typically only implemented as a form of RPC, which is sort of a generic form of system calls. I mean, it's just, and that ties into the pre-existing well-defined RPC interface, which is very 80s. There's something called MIG, Mock Interface Generator. You give it some IDL, it generates a server code, it generates client code, but you know, it is well-defined part of it. It is, and it's more extensible with the table than adding system calls to sysint and whatnot. So you could, in principle, add sets of kernel services that are just function calls. You add it to the library, transparently show it up. You don't have to compile your kernel. And they either are there or there aren't there, but it's, you know, it's not, it's a little bit more flexible than adding system calls, even though it's effectively the same thing. Like I said, you can receive messages in line with KEvent. You have these things that are quite interesting called out-of-line messages, and I don't know, some things use them, they're not used that heavily. I mean, they're not part of what I've been brought up with, so I don't, I mean, they're cool, but I don't know how useful they are as out-of-line messages. So basically you have a message, which is, you know, maybe 100 bytes. It has pointers to other pieces of memory. And if they're small pieces of memory, maybe 30K, it will copy them into the kernel and then allocate address space in the receiver and copy them out again. But if they're several megabytes, tens of megabytes, it will just pack it up. If you're doing a delete on send, you can actually just literally just move that VM memory entry from process A to process B. So it can just, you know, basically just the overhead of packing it up the VM object, sending it in a message over to the recipient receives it, and then has that added to his address space.
So to jump a little ahead of the 80s, that actually does become very useful when you're doing video processing and surfaces and whatnot, and interfacing with OpenGL. There are a number of cases where that's used.
So are you actually doing the page flipping? And
Yeah, as that works, that's, I mean, for the simple case, it's not as flexible as what's in OS 10 and Mock because it requires the allocated memory have uniform attributes across the range. OS 10 doesn't. I do because it makes it easy, it makes it possible to put it into a single VM entry and then put all the pages in an object. And I assume that 95% of the cases that's adequate. And basically, if it becomes a problem, then I can make it more general, but it's easier to implement and debug this way. Port send rights. We already went over that. Provenance. Yes, this is interesting. So when you receive a message, you can actually ask for different types of trailers. So the sender sends a message of this size, but you actually have to allocate a little extra memory. And you can actually ask for an audit trailer. And in the audit trailer, that has the full set of credentials of the sender. The effective user ID, the user ID, the group ID, effective group ID, process ID, you name it, it's all in the audit trailer. And then that gets demarshalled through a libpsm call. And LaunchD actually relies on this functionality when it receives a message to know who's talking to it. But this gives you an interesting possibility of taking things that otherwise live in the kernel, out of the kernel, because you can enforce policy outside the kernel because of the security issues. With Unix IPC, there's no, I'm sure with enough hoop jumping, one can use ACLs and various other features to do something.
Not for IPC.
Okay, but I mean, it's you can do decoupling and basically know exactly who you're talking to. I mean, and this extends further is the signing, the application signing.
I was just about to say, when you start actually really believing in security and you want to do things like code signing, PKI signatures for your executables, then you can do things like have, say, just to set an arbitrary example, have your address book service owning all of your contacts, which if you're, Paris Hilton or something is actually important to keep secure. And then if mail says, hey, I'd like to get the contact information for so-and-so, you can actually validate that it's truly mail who's asking you. And because there's code signing, you can validate that the signature matches. So the trailer is the first breadcrumb in a trail of breadcrumbs you can follow to make absolutely sure that who you're talking to is really who they're talking to, or who you're talking to. And UID 0 is essentially meaningless in that kind of world, right? I mean, so you got big fat hairy deal. You really want to make sure that you can trust the applications. And so without code signing and without trailers, the services model just breaks down.
So this kind of programs can be used to solve elegantly, I guess, the problem that most RPC unauthenticated networks have.
Yes.
You don't necessarily want to accept anything from anyone.
No, you
You
don't.
have to have ACLs in place.
And if you're trying to really create a service-oriented architecture where everything is a service and
Yes.
you put everything into its own address space, so it's not just linking in this library, which now just goes and scribbles all over this database, or right? Because you're really not trusting the applications that much. When you're trying to do privilege and information separation for privacy and whatnot, this is critical. It's an absolutely key building block. You can't do that.
So anyway, that's really all I have to say for my part, because that was really the only thing that needed to change in the kernel. And it's pretty much, apart from the fact that I had to add a pointer to proc and a pointer to struct thread, which the kernel structures for that, there's almost no changes to the common code base. Oh, and I had to have system calls accept 9 arguments as opposed to 8 arguments, otherwise it would panic. Because mock message overwrite wants to send 11. That's 9 arguments, not 7, not 8, but 9 arguments.
That's good.
Which is part of why it doesn't really have the most elegant API, we might say. But apart from that, I mean the mock, because of issues with dtrace and bug in the compact high format processing, I moved it into a module. But the upside of what that showed is it forced me to really eliminate superfluous changes, and it's really standalone. And so it really has no impact on the rest of the kernel. I mean, I had to export a couple of functions that were previously static in Kernevent. That's pretty much it. So anyway, I'll let Jordan go back to it.
Thanks, Kip. So, as Kip alluded to, I mean, if you look at the OS 10 developer guides and whatnot, they don't suggest that you use mock IPC natively. They don't suggest you use MIG because it's really an implementation detail. But the reason we went into such length about it is because this is a crowd that cares about implementation details. You care about what's going in your kernel. So we felt it was worth the airtime to really discuss how it works. But again, this is abstracted away. For 99 out of 100 use cases, you're never going to see mock IPC directly. So let's talk about some of the...
It's an SPI.
Exactly, it's an SPI. So, there's rumblings every once in a while about Apple not using it anymore, but guess what? It's everywhere, and it's too useful to retire. So it's going to stick around for as long as Fortran and maybe longer. So maybe a bad analogy, but you get my point. So the next these green boxes are all sort of bound up together in terms of the technology stack, but in terms of the layering, they kind of deserve their own discussion. So the common object runtime bits are actually really important, and they're something that has to be baked into libc, because when you start doing higher level APIs that actually do have opaque objects, and you're working in a fundamentally multi-threaded world. And I think this is if I had one big stick I was allowed to beat FreeBSD people over the head with, it would be multi-core is not going away. It is folks like Intel and ARM have gone lateral in terms of Moore's Law. They can't pump the clocks any faster without running into lots of problematic effects. So they're going lateral. They're adding more and more and more cores. And of course, they're focusing on power efficiency, which for mobile devices is huge and very important. But if you want to leverage multi-core, That's where most OS people just start humming to themselves. And,
It's an application problem.
yeah, it's an application problem. Yeah. We have p-threads. What's wrong with you? Why can't you just use those? Well, they're a pain in the ass to use. There's a lot of husbandry involved. And one of the first things that Apple found as the Intel architecture started doing that lateral evolution was most applications, did a very poor job of even knowing how many threads to create. And then if you had an enlightened conversation with a more advanced application writer, they asked the very reasonable question, well, how many should I create? 8? 16? Should I look at a sysctl for hardware.numcores or whatever the heck you guys publish and create that many threads? We go,
Well, and how do
no.
applications interact?
Well, exactly, because you're not the only application running. So there isn't an answer to give you, right? And yet if you say, well, screw that, I'll just create 2, well, now on that nice, shiny 32-core machine that the user just bought, yeah, and especially if you're doing Mandelbrot's or something really visually interesting, right, it sucks, it's terrible. So that was a problem that we saw was, we really clearly needed to embrace parallel programming at a fundamental level. So one of the first things you need to do is you need to make sure that your objects are all thread safe, which is where from the Objective-C world, Objective-C is all about retain and release. You can have your philosophical discussions about whether automatic garbage collection or retain release, or now as Apple has gone with automatic retain release. Those discussions can occur ad infinitum, but the fact is retain release is really straightforward, simple to implement, and it has known semantics. Right? If you're going to pass them into somebody else, you retain it, you give them a retained copy, they mess with it, they release it when they're done, and the reference counts bump up and down as appropriate until finally the thing can be garbage collected. But it really makes sense to do that at a low level so that all of your objects can use it. So that's part of the common runtime. And as I say here, some examples are the dispatch object T, the ASL object T, XPC objects all over libc use the common runtime. And what was obvious is because Objective-C has had these memory management semantics since day one, why not just, because libdispatch and XPC and ASL, pretty much every API, in fact, not just pretty much, all the APIs I'll discuss are C APIs. But they can absolutely be used from Objective-C as well. So you can create your higher level Objective-C objects and they all agree on the same runtime, so everything just works.
Kind of a side question, since you brought up Objective-C, are things any better with Swift?
Any better along what axis?
Any that you want to discuss?
Actually, Swift postdates me at Apple.
Okay.
I worked on, MacRuby was my last big language-centric project.
But I thought they killed MacRuby because it competed with Swift.
Yeah, that possibly may have been the reason. But MacRuby used the same common runtime and all the same objects, all the string objects, integers, floats, everything. So it was really cool in that it used LLVM. It turned Ruby into a native code, and you could intermix it fully with Objective-C because it was all the same object runtime underneath. And it's something even Microsoft got right, with their .NET strategy. So. This is the obvious way to do things correctly, and Swift, from my understanding, uses the same runtime, so you can freely mix your Swift objects and your Objective-C objects, and for that matter, your C objects, without hilarity ensuing, and that's a good thing. So, again, the fact that this is baked in at a very low level is why, to answer the very common question I get, why this can't just be imports. Yes, libdispatch is imports, but if you're going to start using it as a fundamental foundation, along with the object runtime and many other things, it has to be in every copy of the system. So to move up to libdispatch, ASL, and libnotify, which are all built on top of our common object runtime. So libdispatch is one of the more misunderstood technologies, not the most misunderstood, but it is a scary thing for pthread programmers just because it's so different. It's actually a lot easier to use than pthreads because you don't even think about threads anymore. The beautiful thing about libdispatch is it is an intelligent thread pool. And what I mean by intelligent is if you have the ability to interface with the kernel through the pthread workqueue APIs, which Stacy Son did for FreeBSD, and we just need to dust them off and bring them back or something, or do a better version of them, or
No,
whatever.
I just like, it was never committed, I
Yeah.
ended up getting about halfway through implementing it one day, and I went, wait, Stacy, oh shit, it's in a patch.
Right, it's been done. So, and the reason I bring up pthread work queue is because, remember I talked earlier about how many threads to create? Well, first off, even if you have no cooperation between applications, if you just say, nah, F that, I don't know how to make that work properly, I'll just have every application use a common API where threads will just be created automatically, it's still a major win because it can retire threads and start kicking them, because if you've got no consumers of thread resources, why keep them around? And in some systems, threads are pretty expensive. I think on OS 10, in fact, they're like $512K each or something. They have a whole bunch of kernel state and some state that goes along with tracking them. So creating 1,000 threads is not a trivial thing to do. You're going to definitely pay a price for that. And it's almost certainly a mistake to do so. Right? You know, you were creating 1,000 because of some hypothetical peak demand, right? So libdispatch already tries to reuse threads whenever possible. It treats them as sort of a continuation. So it's got a whole bunch of blocks that are enqueued on a whole bunch of queues, and it just tries to use the minimal number of threads necessary. And when one of those threads blocks, it can detect that and say, oh, that thread is still doing something. Now I'm going to spin another one up. And threads block all the time. They do I/O, they wait on semaphores, they do various things in highly parallel environments. So it's really, really nice to be able to just say, I don't care. It'll spin up as many threads as it needs, and when it hits a high water mark and it starts going down, it'll start garbage collecting them. And, sorry, go ahead.
Your guess you're saying that libdispatch solves the problem of applications playing nicely together.
It solves the problem of an application playing nicely with the system, and when you bring the pthread work queue stuff in, it's an alternate kernel interface to pthreads, which essentially says, hey kernel, I'd like another thread now, and the kernel says, yeah, not right now. There's this huge Final Cut Pro job running right now, ingesting video at 30 frames per second at 4K. You're not getting another thread right now. And he's like, okay, I'll just keep making do with the 2 or 3 you gave me. And so that's where the cooperation enters into it. And like I said, there is an implementation of pthread work queue for FreeBSD already. So the idea of doing sort of lightweight continuations and whatnot, I don't know if OS 10 ever did this, but it became an obvious thing too of saying, why don't we just shim the pthreads on top of dispatch, and then everything gets done through that same common pool model. It was like the next iteration, which may have been done after I left, I don't know.
So is pthreads work queue, is that part of any like standard, or is that?
It's Apple. It's an Apple invention.
It's the pretty standard.
It's an Apple invention.
Verdicts.
I
I knew libdispatch was. I wasn't sure if the other.
Yeah, it's hard to know who you'd sell it to these days. I mean, I guess you could go to the open group and say, pthread work queue, and they'd go, who? So, yeah, it's not standardized that I know of. It may have been pushed through, but in any case, libdispatch is highly portable, as I'll say at the end, so it's like, you don't have it, fine, I'll do the best I can.
I was
As I
actually
said-
talking to him to say about pulling in the patches. Do we have anything that actually makes having enough use of libdispatch that we can actually see the benefits?
Right. So one of the nice things about having our little NextBSD fork is that we can just pull Stacy's stuff in and say, all right, let's give it a shot. Right? It's a place for us to play, probably the most significantly. And you know, I don't want to get political, but the project is large. It has a lot of customers, a lot of clients, and it's hard to just go, speculatively play in current. And probably should be hard, for at least certain values of hard, because there's a lot of people relying on it, right? They don't want you coming in there and breaking the day with your science experiment. But you need a place to do science experiments, right? Science experiments are intrinsically useful. And in fact,
And there needs to be something above your typical feature branch. I mean, the feature branches are good for science experiments, and most of them just happily die. But there are a lot of things that warrant something above a feature branch, but for a large range of reasons have not made their way to head.
right, they're difficult. I mean, I think rather than a feature branch, the metaphor is more like a lab. Right? You need a place for multiple people to collaborate together, because one guy's basement, mad scientist lair does not equate to a well-equipped lab that lots of people can come and work on stuff together. So yeah, exactly. So Dojo BSD. So anyway, so as I said, task parallelism is made really easy with libdispatch. You just submit stuff to queues. Obviously, if you have blocks in your compiler, that's even better because blocks are closures and they capture all the data state. It becomes really easy to just take existing code and say, hey, you background this piece, and then do some other stuff, and then wait for the results, and then keep going. Or don't even wait. One of the most common paradigms in dispatch is nested queues, or nested blocks rather, sorry, where you do something in your outer block, and then after you have the result, you submit the results back to another queue. So it's called a callback queue. So you just basically enqueue it all within that one block, and so the right thing is going to happen when you're done. And libdispatch gives you semaphores and groups and things as well. And groups are basically just semaphores with some syntactic sugar. So you can also do things like here, just do all these things in parallel, and when you're all done, fire this callback function. I said if you have blocks, they're great, but if you don't, dispatch also has underbar F versions of all the functions for taking a function pointer and a context variable. So you can it'll swing both ways.
So I had the opposite question. So Clang obviously supports blocks, but say that you're on a platform which has Clang but doesn't have libdispatch. Can you still use blocks or do blocks?
Yeah.
Yeah, blocks are just supported by libblocks runtime. I mean, so long as your compiler supports it and libblocks runtime compiles.
Okay.
Yeah, blocks are orthogonal. But actually, it's an interesting story. Blocks were done by the compiler team separately from my team doing libdispatch, and we just happened to hear about each other, and we went, "Ooh, that would be really handy for something we're working on."
And blocks
So-
are basically just C's answer to closures.
Yeah.
And they're nice.
Yeah, and they're really handy. Libdispatch was like most new technologies. It took a little while to catch on, and once it did, it was just exponential growth in terms of users. And to talk about science experiments for a minute, the libdispatch project started with one fundamental question, which is we need a run loop. We need a run loop for the lowest level Unix processes, because there are a number of asynchronous things that happen in a complex system. And if you're writing a daemon and you're writing it in C, and you want to essentially, be able to deal with asynchronous events, well, you need to write some sort of KQ or select or poll loop. I mean, you've seen this in every possible, asynchronous C program ever written. And the X Windows system has its own, XT main loop function. And so we were looking at all these profusion of run loops, and we just said, let's come up with one standard run loop function and one standard set of event registration functions and whatnot. And that was the genesis of the whole thing, right? Because once we started doing that, you know how it is. You start pulling on a thread and you get a whole sweater pretty soon. But one of the other reasons that I want to really stress why all Unix processes really need run loops, even if it's just a compiler-generated one at the end of your main function or something, we debated whether or not to do that too, is signals. And I feel really bad for any millennial who's new to Unix and is working on some code and wants to understand how signal handlers work and what they can do in a signal handler.
Don't, because then we have to tidy it up afterwards. right?
Well, it's worse than that. They don't even get that far. What happens is they go to the first graybeard they find in the company and say, what can I do in a signal handler? And that person says, well, let me see. I think you can printf and set a value, and then another graybeard nearby, his ears twitching, goes, no, you can't. Printf can completely allocate memory during its function, and it's like, no, it can't. Yeah, well, just consider the format string. If you have a %20, and they just start fighting with each other. Pretty soon they're rolling around on the ground, and the millennial just walks away going, I'm sorry I asked the question. Really deeply sorry. And I still don't know what I can do from a signal handler.
And they go back to no.
Right. Dispatch registers trampolines for all the signals. So if you want to have a signal handler in a library, and how many of you have had a library that you linked with boorishly register for a signal that it was sure your application would never want to use, right? Again, hilarity ensues when libraries register signal handlers. Dispatch is no problem. You can have 100 different things all listening on the same signal. Dispatch is handling it for you. It's doing the trampoline and it's calling your handler function on a queue, and you can do anything you like from that function because it's not executing in the signal context. It's merely triggered by it. So there's a number, and the same is true for I/O functions. Dispatch has sources that cover all the different types of events, timed events, I/O-driven events, hardware events. You can do a lot of really clever things through Dispatch. And to the last point, it's Apache licensed, and I actually fought very hard at Apple to get it Apache licensed, and I was sad when it didn't take on a little bit, take off a bit more inside BSD. Though ironically, it took off for Linux and Windows and a couple other operating systems, mostly for Android, because the Android people really, really wanted libdispatch so that they could take their iOS code base and just kind of make some changes to the GUI code and run over there. So libdispatch, it's very cool. Again, as I said, all the dispatch objects, the sources, the queues, the data teas, there's all kinds of sophisticated things that you can do with the dispatch. They're all used the common runtime, so retain, release, create, destroy, work the way you'd expect them to work. You get queues, you get sources, which are just, when something happens on this thing, you queue this block on this queue, and semaphores and groups. There's also actually dispatch data T, which also lets you deal with coalescing of disjoint memory regions, single memory regions. You can split them, you can fondle, spindle, mutilate them, do all kinds of clever things, and does all the referencing, all reference counting for you. So again, everything here is meant to work in a multi-threaded world, and it's just baked into the design, and it's so much better than trying to figure out how to do that ad hoc. I can't even tell you. So my last point pretty much says it all. If you want to learn anything about libdispatch, there's tons of tutorials online. There are sites that
Man pages on Linux.
There are man pages on Linux, yes.
Albeit for a much older version of it.
And I believe we started from the latest and greatest one in NextBSD, so we picked pretty much all the technologies in NextBSD using the last published sources from Apple. So we've tried.
Yeah, it's actually from Yosemite 10.10,
Yeah.
whereas LaunchD was not released in 10.9. There's last open source LaunchD was from 10.9.
Yeah. So there are rumors it's undergoing a rewrite over at Apple, so they're wrangling over that right now. But the 10.9 version works just fine.
Yeah.
So anyway, but we've tried to be as up to date as possible. So you saw me mention ASL as well. ASL is the Apple system logger. We tried to call it the Apple System Service Logger, but marketing didn't allow us to do that. We thought we were being clever. But the key reason for ASL existing is structured log output. Everything is a key value. It's basically a dictionary. And so it's a dictionary with certain predefined keys, and you can add as many of your own. And the API is completely thread safe, so that you can create as many ASL connection types as you want. You can const together objects, different parts of your code, can throw things onto an object before it gets finally pushed out. And it's highly structured. And even if you liked ASL for no reason other than the structured output alone, the multi-threaded friendliness of it is a great reason to adopt it. The fact that everything is in the same character set. I mean, when we started down that particular road, we were looking at our own system logs, and we were seeing some applications were logging in Shift-JIS, some were in UTF-16, some were in ISO-Latin 1, and some that were well-behaved and fairly modern were logging in UTF-8. Syslog didn't care. It's like, whatever string you want to ram down my throat, I'll take it.
Sean mentioned with the audit token that you guys, the value of provenance. I'm not sure in the context of the logger, how does that get used? Because you actually, I mean, how is that? Is actually
I believe there's a system. So ASL also has namespaces in terms of what properties can be set by whom. So you can't overwrite certain properties, or rather the system will just refuse to accept them. I believe that's where the provenance is used by the daemon. So ASL has a syslog-d essentially, but it's called syslog-d on OS 10 because just better to reuse the old name. And it speaks syslog, right? Just to remain Unix conformant, we had to maintain all the syslog APIs. So it basically just says, hey, if you want to syslog to me, I can do it the old way, and it'll still go to a flat file, but via ASL, it goes to a proper database, so it can do things like message coalescing and dealing with runaway processes that want to log their cuts out because they have an infinite loop somewhere in there. So it's a very nice structured logging system, and what it really allows more than anything else is for you to layer additional things on top of it. So because it is a structured key value pair database, in essence, well, not just a physical database, but also a submission system, Apple was able to use it to very good effect to actually start doing telemetry and what they call message tracer. And that was essentially just setting known certain important key values to say, hey, I want to flag these messages for the attention of that thing over there. And of course, you can filter them out too, or you can filter all messages that have that particular set of properties set so that they don't show up in your debug output or they don't show up in your standard system log. You can set policies and filters in place. In fact, you can do filtering both on the client side and on the server side with ASL. So you could say, this client has this filter value of X, and the server has a filter value of Y, and if it doesn't pass my filter on the client side, I won't even send it. So I can slide that up and down as I want to make my client more or less verbose. Then on the system side, you can set your own policy there to say, well, I want everyone to shut up beyond this level. But again, being able to add your own applications for logging on top of the system is really, really important for telemetry.
It sounds like you could build a nice notification system on top of this.
Yes, and has been done. Because again, it's just a source of structured data at the end of the day. And ASL, the server, also has plugins, and so you can write plugins for it which say, hey, anytime any messages which match this particular filter expression comes in, send me a copy, please. And I might send that off to your cell phone or do whatever the hell you want. So it's just a much more well-architected way of dealing with data. And it also encourages you to do something that syslog has generally never been used for, which is to log positive things, right? Syslog is mostly for saying, something has gone wrong, oh my God, right? It's not much good for saying, I woke up at every 15-minute interval, did this thing, and then went back to sleep. And yet, for telemetry reasons, you really, really care about it doing that every 15 minutes. And maybe that's totally expected behavior, but you're monitoring it, right? You want to see how expensive was that to
So
do.
one good thing is because of the structured way the logs is, if instant replay is that now you can feed this information from multiple places into an analytics pipeline, like feed it all with
Yep.
Kafka.
You
and
can write an
see
expert system.
all my iPhones that are out there are doing every 5 seconds this weird thing.
Yeah. I've made this rant on the mailing list, and I'll make it here. With the mobile world now, if you don't have telemetry, you're screwed. Right? You're just completely screwed. You don't know what your product is doing out in the field. You can't look for patterns in the large sense where you have millions of devices out there and you're looking for aberrant behavior, which maybe only occurs once every 36 months, but with a large enough sample size, you're still going to catch that. And you can send power consumption information. You can send the wake ups that occur. You can send sort of when events got scheduled, how often the radio woke up, how often the radio powered down, and you can start making decisions based on it. We used to joke that for the hotspot analysis that we got from telemetry, we could actually start retrofitting Xcode to put code in red, which it just did some data mining and said, hey, this code is used a lot and it's using up a bunch of power. We're going to colorize your code for you, so as you're going past it, you go, whoa, right? It was a joke, but it was also kind of like, that would actually be kind of cool to be able to take this harvested metadata and be able to inform you that certain functions were hotspot functions, or they were eating proportionally far too much CPU time. So,
It seems like a perfect fit for IoT.
IoT?
Internet of
Oh,
Things.
Internet of Things, yeah, sure. Yeah. So, just one of the many building blocks. Internet itself, not huge, not very complicated, but incredibly useful if leveraged properly. So another thing in this tech stack is libnotify. So that's the global notification system. So it's how things let themselves know about other things. And just sort of in the demo sense of this, oops, I can't type away. If I send SIG user 1, I believe, I can type it. let's see, it's in var run. There you go. I can see all these consumers of notifications, and there are tons of them. Again, it started off as a very simple system, very simple API, and we just sort of put it out there and said, okay, guys, now adopt it. And things are just subscribing all over the place to figure out when things changed. So I'm not going to go through all these freaking things. It's pages and pages and pages. And you might say, wow, that's really expensive to have all those notifications. Actually, they're really cheap. And they're cheap for multiple reasons. One, Notify D itself is very small. It's just a broker. Two, one of the most popular forms of notification are actually memory notifications. And the way that they work is Notify D has just a chunk of shared memory, I think 64K or something, very small, and it divides it up into bits. And so, or rather into 64-bit words. And it can bump a generation count in that particular cell every time somebody posts a notification to that named thing. And what that lets you to do very cheaply is cache invalidation. So one of Unix's sins, and it's a sin that is repeated over and over again, is to hit some performance problem, start like Active Directory or LDAP inquiries are taking way too long because this company has 100,000 entries in their LDAP database. So you say, well, I could use a very clever compression algorithm, and I could keep a table internally, and now the round trip time just goes to almost zero now, and now something changes in the LDAP server, and I'm starting to get these weird error bug reports from users saying, I changed my password, or I changed my UID, or I did this mass organizational change even to the database, and I don't see it. The client systems are all reporting the stale data. So, I don't know which rule it is, 2 or 3, never cache anything you don't know how to invalidate. People do that all the freaking time.
Well, the running joke is that there are 2 hard problems in computer science, naming and cache invalidation.
Exactly. So, what the shared memory notifications let you do is essentially say, anytime you have a service out there which can invalidate that cache, all it has to do is just post a notification against this known name and just reverse ICANN strings. And then anywhere you go to use something out of that cache, you do a quick check, which essentially amounts to a memory read. So it's essentially a polled notification, but you're not polling it in a loop. You're just polling it whenever you need to, whenever you're about to read potentially stale data. And if that thing fires, it'll call back you a block or returns you a return status that you can use to make the appropriate decision. And you can just say, I ain't using that data. So that alone has made OS X and iOS so much more sensitive to changes. And there are all kinds of changes that happen. Your default routes change all the time when you've got 4 or 5 radios in a device. And I think 4 or 5 is a small number. There are actually a lot more than that in a phone. When your DNS changes, when the reachability of a key service goes away, and you can have things whose sole job it is just to kind of do little heartbeat checks periodically to make sure things are healthy, and just if it's still healthy, go and send a notification, or rather probably the inverse, when something goes away that you were relying on, post a notification. And now everybody that has some state or a connection that's got to tear down and rebuild can react to that asynchronously and do the right thing. So all of that's done via Notify D. And because it's a low-level Unix API, it'll signal you a lot of different ways. It'll send you a mock message. It'll send you a file descriptor, a message on file descriptor. It'll signal you. You can tell it what signal you'd like to get whacked across the face with, or it'll update one of the shared memory locations for you. So, and because it was written after libdispatch was written, it supports queues and blocks and all kinds of clever things. So, very nice system. So this brings us finally to LaunchD. So, again, it's a marriage of init. On OS X, we had something called mock init, which was the same for mock ports. Basically, when a message comes out of the port, launch a process to go deal with it. So we merged that in. FreeBSD obviously never had that and doesn't need it at this state in the game. inetd or xinetd, if that's how you roll, cron, and then the system startup stuff. And you might say, well, why did you merge all those things together? Well, the first problem we started having early on is we started having things launched periodically to do certain work, and we had them also launched when something came in on demand to say, hey, I need you to do this thing. And, you know, when you're an application platform, you have tons of things potentially running. People are buying software off the shelf. It's creating little daemons to do stuff. You have no idea, right? Many, many things are being done. But now these things all have to start throwing interlocks. Am I already running? Okay, well, I'm going to look for a PID file somewhere in var run, and you know, there are race conditions that abound, and it just, you know, that was quickly becoming a problem. Another thing that became a problem is we realized very early that cron was just too stupid to live. And what I mean by that is cron does a fine job of launching things at periodic intervals. Now, when I say fine job, I mean okay. Because if your machine happens to be asleep during one of those intervals, which Macs frequently are, if I close my lid at 3 o'clock in the morning or 2, and then 3 o'clock is when I wanted to run that cleanup task, guess what? My cleanup task ain't never going to run. And so it had no notion of sleep-wake intervals. It had no notion of run me at least every 24 hours, but hey, I can accept, you know, an almost infinite amount of jitter, so just when you get around to it. Oh, but don't run everything all at once when this machine's been asleep for 4 days, because that would create a thundering herd effect, and that would be stupid, because the user opens their machine ready to get to work, and then everything is beach balling, and the disk is chattering madly, and you're going, oh my god. So cron just couldn't deal with any of those scenarios. Another interesting scenario we ran into was a large video production house started making a lot of noise about the fact that they would take all of the video from the field which was shot during the day. So people go out there to shoot commercials, and they usually do them during the daylight because it's easier to shoot during the day than at night. And they come back around 5 or 6 in the evening with their film, and they hand it off to the editors, and the editors worked all night long to process it, to mix it, to get it ready for the clients to see it first thing in the morning. At 3 o'clock in the morning, the locate.updateDB process would start running, and it would start actually it would start stealing so many I/O cycles away from the system that their video ingest started stuttering. And this made them very cranky. And what was most disturbing to us about this was, this is locate.updateDB. This is not like saving your life. This is re-indexing a file database. This is before Spotlight, right? And we had other ways of indexing files. We would really like this to just happen when it's a reasonable time to do that, right? So what does reasonable time mean? Well, you gotta look at system load. You gotta look at how much I/O is flowing through the system. So enter LaunchD. LaunchD gave us a single point of control for all the processes that needed to be launched and managed. It let us create these dictionaries which would describe when to launch or not launch something. And we could start service setting with these more involved, more complicated policies on things in a way that we weren't running around trying to impose these policies, in 50 different places, like a little Dutch boy with a leaky dike, right? We were putting it in one spot. And we could evolve that as we saw more and more interesting contrived scenarios. So we were expecting in the beginning to have to write a Boolean, predicate language that had all these conditionals and stuff. It actually turned out not so much, right? You could bucket things into saying low priority I/O please, or you could actually give attributes to the things that you launched because you knew who was launching them. And it also pretty much spelled the death of a family of attacks that OS X was prone to in the beginning, which was people messing with the environment. If you can mess with DYLD insert libraries or LD library path and FreeBSD, and you can essentially figure out a way to inject just the right malicious environment variable into a process's environment space, you can make it do some unauthorized things. Having one thing that launches all the things meant we could say, I'm scrubbing your environment by default, you're starting with nothing, and then the person who's setting up this job could say, I want to set just these variables to these things. So just having the environment plist entry, which was a little dictionary of, I want these things set, was huge. A whole bunch of attacks just went away overnight. So again, having a single chain of custody for all your processes makes a lot of sense. Lets you implement all your security policies in one place. It makes debugging a hell of a lot easier because you're not wondering who the hell launched that thing at 3 o'clock in the morning when the customer is screaming in your ear, right? You did. right? And you know where all the description files are, so you know where to look and figure out what the heck happened. So the other thing that it really brought us was about, I think, 2 minutes on boot time. Because the old system starter, which is the RC equivalent in OS 10 parlance, did what all RC-like systems do, which was start at the beginning and end at the end, and just start things up. And when you started saying, I want SMB networking enabled, and I want AFP file services, and I want Bluetooth to be on, and launch the Bluetooth device, or the daemon rather, there were tons of things being started at boot time, just in case they might be needed at some point. And that was horrible for debugging, it was horrible for performance, and these things were spent most of their time just hanging around chewing up battery life for no good reason. I honestly don't know that the phone could have been made without LaunchD, because believe me, the power budget there is way smaller than on that particular box there. And even this, you'd like to have its battery last to the end of this presentation, or to the end of that transatlantic flight, because you're on a cheap airline that doesn't have power, like most of the ones I fly on. So putting all of that stuff in one place actually bought us a lot in terms of, yeah, good.
Just out of curiosity, are you
Yeah.
using some kind of graph to represent the processes, their states and dependencies and all?
Don't have to, because everything, so basically LaunchD listens, so thank you for getting me to complete the thought, because I only got halfway through the thought. The way that LaunchD avoids all of that is it proxies for all the things that you register with it. So if you say, I listen on port 22, LaunchD is now listening on port 22. LaunchD has to run anyway, it's a NIT, right? So it doesn't cost anything for LaunchD to listen for those things, a few kernel resources and whatnot to be bound to a port, but it can look for it, or a proxy of its, can just look for hardware events to know that, hey, a Bluetooth device would really like to now make a file sharing connection with you. It can do things at timed intervals. It can do things when a port request comes in, and it can launch that thing. And if that thing talks to other things, well, they're going to end up talking back to LaunchD again, because again, it's proxying for that thing too.
But I think what he's asking though is how do you deal with the cases where, this process needs to run, but first it needs the file system mounted.
Right. So there are certain notifications that get posted when things like, I think for root, LaunchD doesn't run until root's mounted, so that particular dependency is handled for you. But a more popular cases, I can only run meaningfully when I have networking. And in fact, there's been a lot of race conditions, actually a number of sleeps and whatnot in our existing startup scripts, which basically say, well, I better run DH client on all of my interfaces first, and then wait a little bit, and then maybe start launching my network daemons, because if I do them out of order, the network daemons are going to come straight up and go, bleh, I can't.
We're actually seeing an issue with that because we're running the RC scripts, running all the default stuff in the RC scripts, but we're starting dev D, but when we try to start dev D by LaunchD, somehow the timings change so that when Sean has DH client inform the DHCP server that this name is getting this IP, it doesn't actually inform them. The name isn't getting passed to the DHCP
Right.
server for
So-
reasons we don't understand.
So that's where a little bit of predicate logic does come in, where you set your dependencies and say, I depend on this, 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 and this, and launch me when those things are all true. So LaunchD does keep, to answer your question, yes, there is a dependency graph of sorts and a set of sort of match criteria, but it doesn't go end deep, right? So that's, I guess I answered the other question, which is, does it have to keep a DAG?
Right.
No, it doesn't.
Okay.
It doesn't.
I was actually also thinking of the scenario you were raising initially about uploading the video stuff and then the 3 AM task running. How do you solve that problem?
Because you say the 3 AM task can only run at low I/O priority. As I said, that's one of the things that you can decorate its job to say,
I see.
put it in a low priority queue. Or you could, if that hadn't worked, we would have put a, only run when system load is less than n, right? So that would have just been one of the trigger criteria. So LaunchD says, yeah, it's 3 AM, but the load is 9. So you ain't running.
And you've never run into starvation with this scenario?
No, no. I mean, this is the one, if I could make another point here, this stuff works, right? It works in million unit quantities across the world. If there were any fundamental design flaws, believe me, they were found and stomped on years and years ago. I think LaunchD was done, 7 years ago? Yeah. Right? It's been around for a long time. And it's, in fact, if anything, the evolution of it has been hard for us because it started out with a much more straightforward design, and now it's been, people are coalescing stuff and writing proxy things for LaunchD because they didn't want LaunchD to subscribe to these IOKit events, and now there's an additional thing in the mix, which again makes sense architecturally because LaunchD is PID 1. LaunchD cannot crash. LaunchD cannot have a bug.
But we're stepping in after 8 years of evolution and
Right.
dependency development.
Right, so we're coming along kind of going, oh.
And
okay.
also, we had to roll our own for bits that are closed source, so.
Right, like XPC, You've heard XPC mentioned a couple of times. That's the structured dictionary IPC that sits on top of the lower level IPC mechanisms and lets processes essentially do, not RPC per se, but exchange structured data back and forth. And have on both sides the appropriate libdispatch handlers already registered so that when this particular dictionary item has this data in it, this thing gets invoked for you. You just don't care. And it's very nice, but it's not open source. So we kind of had to come up with a reverse engineer and work like. And since we've done that, I've actually gotten some pokes from Apple going, so you guys really care about this? Yes, we do. Let's see what we can do, right? They're being cagey, right? Because of course, these are engineers who don't know whether they'll ever be able to achieve
Marketing and legal.
But yeah, a lot of hoops need to be jumped through. But as I said many times when I worked at Apple, if you guys would only use this, you give me the ammunition I need to open up more stuff. But when you go to legal and say, I'd like a different license on this, they say, you haven't eaten the last thing we gave you. It's kind of a difficult one to make. So, popular myths about LaunchD I want to dispel real quick. Number one here is LaunchD groks XML. Wrong. LaunchD knows nothing about any data format at all.
Sure.
LaunchD has its own little structured dictionary format which is completely agnostic, which LaunchCTL uses to talk to it. So basically when it registers a job, it has to have a data structure. That's not XML, that's not YAML, that's not JSON, that's not anything. It is a serialization format of LaunchCuddle's internal data structure. LaunchCTL is a user-land program that just establishes a trusted connection to LaunchD using the security trailers to prove that who it is, and or rather the person running it is who they are. A number of things are conveyed through that handshake, and then it is what reads the XML files. And in fact, in our implementation, we for FreeNAS, we're a JSON shop for FreeNAS 10, so we use JSON files. We don't use XML.
That's awesome.
But it's totally irrelevant. The one thing is, everyone likes the fact that it's JSON, but the fact is it's irrelevant. That happened to be easier to import Jansen, which is the JSON library that Jacob wanted to use, than it was to get libcf working.
Right. And he wrote LaunchCuddle from scratch. Right, so he wrote his own LaunchCTL. And all he had to do was speak the right protocol to LaunchD. LaunchD said, that's fine with me. We don't have code signing or anything, so there's no additional checks, but it wouldn't have mattered even if we did, because we'd have just signed it, right?
Last week, I wrote my first LaunchD XML program, and I really couldn't figure out the format of the XML, so I ended up going to the App Store and finding a program that would make the damn XML for me. And then after that, I could reverse engineer it and do my own. But it was a pain in the ass. I'd much rather have JSON.
Well, yeah, there are plist editors. This is more of a religious issue than anything else. I will say one thing that Apple did right, though, was it picked one. It picked a format, and the plist DTD, the property list DTD comes from NextNet.
Yes.
Right? This is something that they just acquired along with Next and said,
And
okay.
interestingly, PLUtil converts from XML to JSON.
Is that right?
We know, but we're not entirely sure why.
Somebody was hedging their bet somewhere.
Right.
Yeah. That was from a different team than
But it basically PLUtil on your laptop, so you take an existing OS X plist and you can feed it to PLUtil and it will produce JSON out, which barring path chain differences between FreeBSD and OS X, will work for us.
Right. So so that's how agnostic it is. And yeah, LaunchD will launch things based on the files being present and directories having a file dropped into them. One of the first things I did was actually turn postfix off by default and then put a LaunchD job which watched its spool directory. So then if you just did a mail from the command line and a mail message dropped in there, postfix would go beep and go deliver it, right? And then it would shut down. Because no one wanted postfix running all the time for something that happened almost never on an average laptop. So yeah. Again, another popular misconception is really complicated, that we took, all these things and we somehow, the amount of code that's in LaunchD represents all the things that were summed together, aggregated somehow. It's not true. It's actually a very simple code base.
And the control flow of LaunchD is not trivial, but LaunchD is a few thousand lines of code. That's it, period.
It's very small. It's really having the cojones to use it and to refactor all your startup stuff, to start saying, I got to get out of this linear mindset of just starting all the things. Or, one of the things I love, I get this request every once in a while from some of my friends, like, how do I launch something when all the other things are launched? I go, oh God, what are you trying to achieve? No, I just want to run something after everything else runs. Okay, so you want to schedule it for the heat death of the universe? Because that's technically when nothing else will ever run, right? And they just can't get their minds around this notion of, wait, what are you actually waiting for, right? And once you have that conversation, it's like, oh, so I can just depend on, or I can just, talk to that thing and it will appropriately be there when I don't have to wait around just in case it's not there yet? Yes, it's all on demand. Everything is on demand. So, not complicated. And the other thing that from the recent systemd, LaunchD discussion that came out of last year's EuroPSDCon talk I gave was, people saying, oh my God, Apple took Unix's keep it simple and beautiful and small philosophy and then clubbed it like a baby seal. And, let's be honest, this isn't your daddy's Unix anymore.
Well, let's be honest that having dozens and dozens of scripts that are all mini daemons isn't simple.
No.
That's just bullshit.
It's just exploiting your common.
It's just bullshit. Yes, it was really simple when it was maybe 5 scripts and just a init. That was truly simple, and that was truly the right way to start
That was on the
things.
PDP-7. I remember.
Well, okay, maybe sometime more recent nonetheless, but nonetheless, but it's not basically it may be simple to understand at some basic level in terms of how you wrap your head around it, but from an implementation standpoint, what is sitting in rc.d is not simple.
No, it's not.
So here's a funny story that makes me want this to be released already. Imagine you're running some kind of web front end and the web front end listens on various ports, like say 80, and you want your web front end to be able to send messages to reconfigure things that restart services and whatnot. So some Python programmer who was at U decides that they can just go system, you need service restart NTPD or service restart foo. What they don't know, because they're not 35 and have been burnt by this before, is unless you set close on exec on all the fucking file descriptors, NTPD starts listening on port 80. Yep. Right? And so what happens, is, say you want to then restart your web service because it needs to go away. A whole bunch of other stuff is now services that in no way should be listening on things like this have inherited some of the environment from the things that call service.
No.
Right? Because they're not running the startup script anymore, they're running the process service, and we haven't abstracted it out to have a daemon that listens on a port for service commands to have a blessed environment, which mostly sounds like LaunchD, right? So this is one of the nice things about this is it's not just about avoiding security vulnerabilities. It's stuff like what path is invoked and what file descriptors are currently open and all that other kind of.
It solves that problem once and for all.
Right. And to your point, not everything is static at startup time, right?
Yeah.
Stuff arrives later.
Yeah.
Stuff gets installed later.
If I may, another example which is very similar to that is, I originally come from Greece, so usually my MacBook is set to the Greek language, so locale and all that. So I'm on call for something at the box where I used to work before, and something crashes. So I SSH into the box and it does a service restart. And 2 days later, somebody calls me and says, why do we see in the log files these weird, hieroglyphic characters? That's free. I know where that.
So it inherited the locale of your login. That's gorgeous.
That's beautiful, that's
I'm
awesome.
gonna start using that now.
That's awesome.
Thank you.
A couple dump notes. I love the fact that you dropped a 0 day on everybody in the room, which is that thing you mentioned about the runtime linker not scrubbing its environment is still active in 10.10.4.
The linker doesn't, yes.
Yes. It's the beta 10.10.5 or higher, I think, fixed it. Anyway,
Yeah.
the other thing I love LaunchD for,
Actually, that was a historical issue. If I dropped the 0 day, that was completely
it's still
inadvertent.
there.
Okay, well, so the
Yeah,
DYLD in certain libraries and stuff, that's been around, because every time you try and remove it, all these developers go, oh my God, no, I use that for debugging, right? But it has to be very carefully controlled, just like task for PID and other
Yeah, I
things
never
that-
added task for PID for exactly that reason, although, and I may at some point need to add it if we add a crash reporter. I basically, I'm not actually a security, that hard about security, but I'm just like, what are the legitimate uses for that? And
Well,
then-
if you look at my tweets, I actually tweeted a 0 day on 10.10.4
Yeah.
with that exact problem.
Okay, okay.
That still works.
I'm
And,
not surprised.
I love LaunchD because one day I sat down and actually was scratching my head like, how the hell is SSH log agent launching? Automatically.
Yeah.
And it can register listeners for environment variables so that when any C program, shell program, or anything, even an echo, tries to read that environment variable, boom, up comes on SSH agent. It's got custom integration with read keychain. It's just awesome. I now think that BSD, Unix, Linux, and even Windows now suck if you have to use SSH because Mac is the best now.
I was one of the people who worked on that, so I'm happy to hear that. So yes, if I have a summary, is that yeah, the world has changed, and we are now running on devices like this. not
that are
just-
more complicated than,
Yeah, like I said, this thing has got what, a Bluetooth radio, a near field communication, Wi-Fi, the LTE network radio.
dozens of daemons that all do things that are actually important.
In fairness to Unix, it was developed in the early 70s.
Oh, absolutely,
So,
absolutely,
It was a much different world then too.
absolutely.
That's the point, is
Yeah.
that our preconceived notions about what is correct
Right.
were correct at a
Right,
time and a
right,
time and
Right.
place.
In the earlier talks I used to give about the history of Unix and kind of the legacies, I put a picture of a VAX 11780 with a big thick power cord going to the outlet. And I said, that never got unplugged. If you unplugged that, people came with sticks and knives to your office and had words with you, right? And it never moved. Nobody changed the network address of it, right? I mean, that's where we came from. And I mean, they've even had machines at universities that got bricked up behind walls, and no one could find them anymore, but they were still running somewhere until somebody traced a little cable coming out of the drywall and going, where does this go, right? And the true stories, right?
It sort of reminds me of James Gosling once said that back in the beginning, there were something like 100 servers, machines on the internet. He had root access to all of them. It's kind of like that, right? Those days are history.
They may have been on purpose. Yeah, I still remember @sign C70 to go to MIT AI on the ARPANET. It's one of my favorite places to go. Back when it was so. Anyway, so resources next
Actually,
steps.
I thought we were agreeing we're going to edit that. You said that ISO doesn't image.
Right.
doesn't.
So I was just going to say, if you go to github.com/kmacy/nextbsd, you'll find the sources. And right now, the only way to build this is from source, because that ISO image turns out it's actually Cactus.
Yeah, so basically something about booting with LaunchD makes hoses disinstall, which
Which used to work, so I don't,
well,
I don't know what happened.
I don't know. So
The
yeah, so
Dark
we'll
Angel-
just
The Dark
yeah,
Angel
so
demos have visited us.
we intend to within the next week or have start building nightlies that work. Unfortunately.
Right, so yeah, we'll have nightly builds up, we have a little VM that's already set up to do this, running in Colo, and so there'll be, a little bandwidth to it, we'll put out nightly ISO images.
So right now, you suggest Launchd is up and running and then still running stuff through RC, or have you already?
There are four jobs that are launched by Launchd. It launches Getty,
Okay.
it launches DevD,
Alright.
it launches
SSHD.
syslogd and notifyd. Okay.
Okay.
And
And
so
everything else
basic-
just it launches RC and then.
Then RC is launched. Oddly enough, I don't know why, but look, it's been refactored so that launch control actually after passing these jobs will launch RC. So, but it's happening at the same time because what happens is the way it's worked initially on OS X, or the way it works on OS X is Launchd is started as a init. Launchd files off launch control with the argument bootstrap, and which means pass me all the jobs, and then it goes and iterates through all the jobs. Jacob's done his own thing. He passed the bootstrap, passes these jobs, and then I was initially doing it from Launchd, but he's actually running runcon from launch control, but it really doesn't matter. I mean, the fact of the matter is,
And the reason why it's executable, because I went to rip that out, I was like, oh, that's a layering violation. And I realized single user mode is special. And somebody needs to go and set the TTY in the right modes and to deal with.
and it's
single
easy.
user.
I think it's
So-
easier just to do that in launch control than
Right.
debugging Launchd to do that.
Exactly. So it basically just launches launch control once in the special mode. And as Kip says, if it's single user, it inherits some variables, say, oh, I just want to run a shell and stop. Otherwise, it goes and basically checks back in with Launchd and says, here's a bunch of things in this directory, and I'm just going to feed you the JList files, as we call them, because of JSONplists, and it just works. And SSHD is also right.
It's, okay, I guess I don't have it in mind, but SSHD is started as by, so yes.
But I mean, the progression is remarkably similar to what Apple did, which is, start with just a few key things and then launch System Starter, or in our case, launch RC, and then just start pulling stuff out.
But
of
there's
RC
some weird issues that basically, there's one open issue is the config D. Can you issue? Matt?
Right, so config.d on OS 10 is what watches all the network ports and fires off the DH clients on them, and also knows when routes have changed, and so it's kind of the missing piece. I guess we have network D, which Jakob has been working on.
Okay, we have, so but yeah, that's the one issue, the one piece that's
Network
not,
interfaces are special, right? They're
one, not one, the
namespace.
one part of the system that's not complete, because otherwise you could simply just take the parameters and convert it to something that Launchd understands by and large. But the problem is the scripts like default route are actually little mini daemons that go and wait on this. Has this happened yet, or that? Have I done that yet? As devd? Well, I'm going to wait for this many seconds and print out
Yeah,
periods.
Right.
And we need this. Right now it works for the common case, but I mean in terms of that's the one sort of.
Right, because I would think that you'd be able to like do something like poke something special into devd, and then, devd's got something listening for example, like the route change or something. That's not really what devd's for, but you could probably.
We've been trying to resist that impulse for exactly that reason.
Yeah, I think essentially the bit that's missing is the network enablement part of it.
Right.
Or something like called network view. Just
No, we'd
everything
rather
else
just
is-
isolate that. devd
Yeah.
does its job and basically
Right.
just,
Right.
it's not complicated. It's just,
Right.
because default, it's basically a role that default route plays, but a little more sophistication.
Right. We would ideally like to have devd be the equivalent of the IOKit events coming from the kernel.
And we basically, they have plugged devd into Notify. It's just,
Right.
So there's a problem with the way that Wi-Fi works, which I refuse to fix because I'm too busy.
Okay.
The problem is, what starts WPA supplicant, right? And supplicant runs for 802.1x as well for Ethernet, not just Wi-Fi. So there is some silly ways, and I know John's looked at it, and a bunch of other people have looked at it, where you can have you dynamically create the interface because you have a devd rule that plugs card in, creates WLAN0 interface, it sees that and it wants to start the supplicant, run the RC script, the network RC script that goes and runs it.
Right.
2 copies get run in parallel or something bullshitty like that, because you've got these magic shell scripts starting from different
Yeah.
paths instead of having one thing that makes the decision when to start. Did you ever figure out why it's doing that?
I think it has to do only really, yes, but yes, I did figure it out.
Why is devd
Part of it is
starting
that boot is
WPA
really
supplicant?
special, that we want to do a static kind of, let's get everything in the same state during boot as opposed to handling things that are asynchronous.
Right.
And the two paths are very different. And there's one case where they both run, and that's what does that.
Oh no, it's because something's triggering the network RC script on the interface.
DevD should not launch WPA supplicant.
No,
You
but
should
it's-
configure rc.conf
No, but
and then
it's-
start the RCD.
No, but it's something to do with something is starting it dynamically, much like bringing up an Ethernet interface that's configured for DHCP. Right?
Jordan, if you send me I'm sorry, this is non sequitur. Can you send me those slides, whatever the latest version is, or update them so I can put them online on fixbsd.org?
Yeah, I'll do that. So the point I just want to make is yeah, there are thorny issues. We need a network D. We need a dev D. I think dev D, in fact, we could probably simplify dev D a little bit because I think it's already grown some.
I think maybe you can just integrate DevD into
No,
No, that's the whole point we're trying to avoid.
Yeah. The dev D, LaunchD really wants to remain simple. Like I said, LaunchD cannot crash. If LaunchD crashes, it's the same as a kernel
The
package.
reason you don't want that is because DevD is doing syscalls to do things like load kernel modules, and that can actually take time.
Right. Now, that said, with mock ports, mock IPC usable to talk between the kernel and user land, it could be we can come up with a richer pipe for sending kernel events up to something that handles those. Again, I wouldn't suggest that be LaunchD, but LaunchD also has a notion of LaunchD proxies, which are processes that basically are peers of LaunchD in terms of linking with certain libraries or certain event sources, but then they talk to LaunchD to get the process actually launched. And that was because nobody wanted to link LaunchD with IOKit for good reasons, right? So again, we can leverage that architecture in many different ways to say LaunchD still remains the progenitor of the actual processes. It still remains the one that can look at the policy, the dictionary, and say, is this really appropriate? Do I want to do this now? And other things can simply be trigger sources. And I think that's the right way to refactor it. And again, we would love to have LaunchD manage the DH client processes and whatnot for configuring interfaces, and then maybe even refactor DH client a little bit to sort of, once they've gotten their release, to post notifications. And okay, it's up. I've done my job, and now I'm hanging out anyway because I'm the one doing the timeouts and reacquiring releases periodically. So as long as the various pieces of FreeBSD become asynchronous in their expectations and they map into the same model, stuff just starts to actually kind of simplify itself, and you start seeing, oh, I don't need to do this parallel work over here. I can simply generate it, I can do the minimum and generate notification, and LaunchD has got a JSON file that says when that notification is posted, do this thing. And just make it everything you do on the desktop of OS X through launch services is launched by LaunchD, right? You double click on an application, you, the user, are not running that app. We're sending a message to run that application. And it's got a connection to the Windows server, and there's some privileged stuff that's done to make that application be able to render itself. But LaunchD is a progenitor of everything. And
Okay, next question.
yeah.
What about jails and stuff like that? Sorry.
They could certainly have their own LaunchD.
Right.
Yeah, I would expect that. In fact, again, as Kip was saying, there's been a lot of evolution. In the early days, there were actually, I believe, 3 LaunchDs. There was the system LaunchD, there was the per session LaunchD, and the per user LaunchD. And they ran with different privileges, and the notion was, obviously the system LaunchD does the obvious things. The session one was for your session, and the per user was for any jobs that you submitted that you wanted to run in the background after you logged out, but should still run as you. And now there's one again. So I think essentially what somebody did is they figured out, wait, it's silly. We don't actually need 3 instances of ourselves to do this. We can simply have one instance that sets its effective UID appropriately, and the session and user thing was always a bit fuzzy. So they went and they simplified it again.
Okay.
So for jails, yeah, certainly we'll have our own LaunchD hooks for that kind of stuff. And of course everyone's talking about Docker apps now. Who knows? Any other questions? Okay. Oh, one more.
Yeah, is this something that is going to go into FreeBSD eventually, or is this something that you kind of wish would go into FreeBSD?
I think wish is the right word.
You're making a bit.
Yeah, boy, and I would That would be the shortest time to lose a commitment after a commit in history. If I just
Well, I mean,
Some of us commit.
I think, I mean, this is sort of one of the issues that, you know, the sort of, where you manifest the issues with the sort of consensus model of having only a single source base that is gospel, whereas you look at Linux, and, you know, there's what Linus tends to, and that's, but there are different maintainers who have trees, and then there are distros, and no one says that Red Hat is not Linux because they patched it. Ubuntu is not Linux. I mean, there's diversity in the ecosystem, and they can all develop ideas in parallel, and they can all come to full fruition without stomping on each other by any stretch of the imagination. And then they basically, and then when someone concedes that yes, that was a good idea, I'll adopt it, they can adopt it. And
Or your Red Hat and just make system be the default.
well, no, but that's you're missing the point. Is that the point is that there needs to be. I mean, there's more street cred has to be given to PCBSD, and maybe, you know, if I can get enough people, or I have enough free time, or, you know, basically don't have any contracts, you know, develop NextBSD into something that's approximating a distro where things like package management actually works and doesn't delete your packages when you install new ones, and basically has an installer that appeals to an audience wider than, you know, the hardcore FreeBSD users, and, you know, also adopts new technologies as they come up and are implemented, like, you know, vulnerability mitigation. I can't actually speak to the quality of Hardened, but the notion is that, I mean, that kind of thing is something you want to, I mean, I would think one should adopt more aggressively, and there are people who think otherwise, and so basically there is no reason why, you know, people who want it shouldn't have it in a working system and shouldn't have to add this patch and add that patch. I mean, there should be usable source bases that develop it that people can just install and say, I want, you know.
So I think the points. I mean, there's really no wrong answer here.
No.
Right. So to answer your the man in green's question, kind of a little bit more fully, if you know there were a bunch of pitchfork and torch wielding villagers at my doorstep tomorrow saying, yes, you absolutely must bring this into current, I would say, okay, you know, if there's enough of you and you all agree, I think that's fine. However, to Kip's point, NextBSD doesn't just dry up and blow away the next day, because it still remains a nice point for being able to try the science experiments like we talked about in the beginning of my talk. So, you know, there may be divergence and reconvergence lines, and I think, you know, if you talk about the forking model in the BSDs that most folks actually wished had happened versus what actually happened, they wished that some group of eager young Turks had gone off for a while, proven the concept, done the coding, done the hard work, and then been welcomed with open arms back into the mainstream again when, you know, they had sufficiently proven it. Unfortunately, history didn't quite work out that way with, you know, Dragonfly BSD and whatnot.
CVS also made that really hard.
It did, but so Git alone is, I mean, you know, I started out as Git-tarded as anybody else and going, oh my God, I don't understand this. This scares me, and Shin had to explain how to use it. Still has to explain how to use it frequently, but I embrace it fully.